Hey everyone, so me again. I'm here to bring you your next lesson for honors geometry. So this is very much an extension off of what you did in class on either Thursday or Friday. So I would maybe have my notes out or my workout from that class because we're really going to build on it here. So if you see, this right here is the same exact objective, right? So using knowledge of rigid transformations and congruence, I will analyze and apply triangle congruence criteria. So our rigid transformations that we've spent, man, it's almost been like the entire quarter so far, right? So like the past few weeks on were translations, and these are the only ones, reflections, and rotations, right? And what makes them rigid is that they maintain their shape and size when that rigid transformation happens, right? The original one and the new one, the pre-image and the image, are congruent to one another. They have the same area, they have the same perimeter, they look exactly the same, right? And then the combination, right? The series of rigid transformations as well, so not just them individually. So if you can transform one into the other through a series of rigid transformations, that means that the two are congruent to each other. So that brings me to my next word I circled, congruence, right? And you at this point, or even if this is the first time you're saying it, this is the symbol for congruent. Congruent means that they have the same measure or they have the same length, right? But we're not going to say, like we would say segment AB is congruent to segment CD, right? And what we really talked about a lot with congruence was that corresponding parts, right? So corresponding means that it's like in the same place, just it's like where does it end up when that rigid transformation happened, right? So like if I was moving to a new house and I was going to put my TV in the corresponding place in my new house, it's going to be in the same location but in a different house, right? So like it's the same location. So corresponding parts are congruent. And that's true for angles and sides. They all have to be. So what we did in class today, or the last time I saw you in class, or whoever your teacher saw you in class, you started to talk about some shortcuts or triangle congruence criteria, right? We didn't necessarily every single time need to know that every corresponding angle and every corresponding side was congruent. There was some things that like now we have enough information to prove or to say that these are congruent. And then by default, once we know the triangles are congruent, all of the other corresponding parts that we didn't know anything about are to also congruent by this definition. And so what you guys learned about was you learned about side angle side congruence, or SAS, and you learned about side 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 congruence. Right? And you had an opportunity to explore this in class and kind of see this in action. And so what this means, and I think the big one for you to recognize here is the angle is between the two sides, right? This is, I know three sides. And this is triangles. Like this is plural, right? If I just give you one triangle, you can't prove congruence, right? Like what is it congruent to? So I need two triangles. And if I know these sides are all congruent, I can say, let's see, let's say it's A, B, C, D, E, F. And you want to be careful here. Let's say I control the first one. Triangle ABC is congruent to triangle, well, A is between 2 and 3. That's E. Then I went to B, which is between 1 and 2. So E, F, D by side, side, side congruence. Right? If it was side, angle, side, I would need to know an angle between two sides that I knew were congruent. You need two triangles for this. If you only have one triangle, that's not enough. Okay. So we're going to review this a little bit more before we really dive into building on this. We're going to build on this and kind of look at some other triangle congruence criteria. So let's take a look here. So this is what we started with, right? This is what you got in the last video lesson. So write a congruent statement or congruent statement. So I'm going to do it for the sides first, right? Corresponding sides are congruent. So FG, segment FG is congruent. Well, which one has two markings? This one, KL. You know what? I'm going to even put some color on it. So it makes it even easier for us to talk about. Okay. Now let's say my next one, I'm going to do GH. GH is congruent to LM. And finally, FH, and if I switch these letter orders for this statement, it's fine. I like to try not to so I don't get confused later. It's congruent to KM. Amazing. Okay, now let's look at the angles. So in this case, I could just use one letter. I really want to emphasize the importance of using 3. So I'm going to use 3, but you could use 1 because if I say angle F, there's no confusion. You guys would know exactly the angle I'm talking about, but there will be situations, and we'll look at them in this video, in which that wouldn't be so clear to us. And if you're like, multiple angles have this vertex, remember that word, then you need 3 letters, and you need that vertex to be that middle letter. So if I want to talk about, I'm going to use 1 here. So angle F is congruent to angle K. Oh, no. I need the symbol. It's going. Right, so that's this angle and this angle. Let's see. Angle L is congruent to angle G. And finally, that's this right angle. Angle H and angle M. You guys remember what all 3 angles of a triangle add to? It's called triangle sum theorem. All 3 angles sum, which is add, to 180 degrees. So if you know 2 angles, the third one has to be the same. Isn't that crazy? Amazing. And so then now that I have all of that, now that I know that all the corresponding parts are congruent, I can write a triangle congruent statement. I'm going to do that up here. So I control how I want to write the first one. So let's say I say HFG. What corresponds to H? Oh, M. This matters. Order matters. M, this corresponds with H. And then I wrote an F. F corresponds with K. And then L. Oh, I forgot the congruent symbol. Amazing. So this is what you did in the last video and what we started our last live session with. And then we dove into some of these triangle congruence shortcuts where we didn't need to know everything. So I'm going to take a look at these. And it says triangle congruence criteria are the following triangles congruent. Fully explain. And I want to emphasize that fully explain because we're really building towards writing what we refer to as formal proofs, where we would prove triangles congruent. So the earlier you start this process, the more time you will have to really develop an in-depth understanding of it. And that's why we want to start this now. Like we want to list everything out. And so I'm going to write out the things that I'm given. So I know that BC is congruent to DA, right? I know that from the markings on there. What else do I know from like what I'm looking at? I know that AB is congruent to CD. This is stuff that's given to us. Right? So when I'm saying fully explain, I know this because it's given to me. Now get yourself in the habit of this. Is there anything else you know? Well, there is. These 2 triangles share a side. They share side AC. Right? So I can say that AC is congruent to AC. Maybe you remember what that's called. The reason this is true is the reflexive property. It's because it's a shared side. right? They share that side, so it is congruent to itself, right? Something's equal to itself. It's congruent to itself. So I can go ahead and put a marking on there. So I really want you to think about, I'm really starting with when I walk into this, what do I see? Like, what is blatantly given to me? And it is these two things. This one is kind of like, I might need to look around a little bit. It might be hidden behind something, but it's there. I don't need any other information other than to just look, right? And so that's what the reflexive property does for us. Like, we can go and look for it, but it's not necessarily like told to us the second we walk on a scene. So that's enough information, right? I've got 3 pieces of information here. So with those 3 pieces of information, I can now conclude that triangle ABC is congruent to triangle, and be careful here, A in this triangle, this angle right here is between green and red. So I need the one between green and red. Ooh, that is tricky, right? Angle C. B is congruent to, or corresponding and congruent to, angle D. And angle C, this one right here, is actually congruent to this one down here. It was almost like it was a rotation that happened. It's not almost, that would be the rigid transformation. CDA by side, side, side congruence. Right? You're really writing a proof here. Amazing. Right? And so this would be a great example of, if I wanted to talk about this angle right here, I would need 3 letters. I would need to say BCA, angle BCA, or I would need to say angle ACB, right? Because if I just say angle C, there's 2 angles that contain that angle C. So you want to know, well, like, what is forming it? Where is it coming from? Where is it going? So include that in there. Okay, let's look at this next one. So let's start off the same way. Let's see, like, when I first look at this, what's told to me? What do I know? Well, I know that AC is congruent to EC, right? I also know, this is also marked for us, BC and DC. BC is congruent to DC. My reason for both of those is that it's given to me. That's how I know that it's true. That is part of my explanation. So I'm going to need one more thing. And what is something we talked about, the reflexive property, is a shared side. Well, these 2 angles are going to be congruent to each other. And this is another one that isn't directly in front of me, but I should look for it. I should look for a shared side, or I should look for, maybe you remember what it's called, vertical angles. So vertical angles are formed by 2 intersecting lines. These opposite angles will always be congruent. And the reason behind that is, let's say I just told you one of them. Let's say I told you this was 20 degrees. Well, you're going to know this other angle because it forms a line. And a line is 180 degrees. A straight line is 180 degrees. So this would be 160. Oh, look, another line. This would have to be 20. This would have to be 160. So if an angle is formed by 2 intersecting lines, the opposite angles, not the adjacent angles, the opposite angles are going to be congruent because they're vertical lines. They're vertical angles. Wow, sorry. So I know, and this is something to look for. Angle, I need 3 letters. ACB is congruent to angle ACB ECD because they're vertical. So what are you given? What is in front of you? What do you need to maybe dig a little bit deeper? Like, it's there, but you got to look for it. And that's reflexive property, shared side for sides, and vertical angles for angles. Okay. Oh, I didn't finish. Ooh, I got excited and then I wasn't actually finished. So now that I have these 3 things, I have 2 sides and an angle. Oh, look, 2 sides and the angle that attaches those 2 sides. That's between. So I can then conclude that triangle ABC is congruent to triangle AB. So I'm going to go from, I went from the pink to the purple, EDC. Right? So really look at it and figure it out. I controlled ABC. If I said that differently, this would look differently. Amazing, right? So this is an example. Oh no, I didn't finish again. By side, angle, side congruence. So this is an example of, like, this was really what you've done over the last few lessons. So introducing congruence. Look, this would be either two reflections or a rotation, right? I could get from ABC to this triangle down here by just spinning it around, and it would lay on top of it. They are congruent from rigid transformations. Okay. So now we're going to explore a little bit more. So I'm going to take you to these two websites and play around with them for a few minutes. Let's see. So you guys did side, 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 angle, side. I want to look at what we refer to as angle, side, angle, and angle, angle, side. So if you take a look at this website, it says set the angle, side, angle, then move the two endpoints to make a triangle. So I'm going to move this and move this. Are you able to make one unique triangle for the given combination? So I'm going to pick, look, angle, side, angle. It's two angles and the side that they share, the ray that they share. So as I move this around, right, like I pick how long I want this to be. I just want to know, now that I've done that, I pick how long this is going to be. You see how they only intersect once? It's not like I can do something different that forms another triangle. It's 9, 12, 9, right? Let me move it again. Let me change the side length. There's only one place that they intersect. Let me change this angle. Okay. I don't even know if these are going to intersect. They're going to go out. Oh, it was because I was over 180. You see what happens there? 120 and 80, I'm over 180, so this can't form a triangle. A triangle only adds to 180 degrees, right? So I could play around with this and really see that as I'm doing this, I'm only ever, like, there's only one place that these sides could possibly intersect. Like, I cannot make another triangle. If I have these two angles and this side between them, I am forced to only have two other sides. Like, I don't need to know any other information. So angle, side, angle proves congruence. If I have two triangles, and I know this angle is congruent to this angle, I know this angle is congruent to this angle, and then I know that the side between them is congruent to each other, these two triangles will be congruent by angle, side, angle. But let's look at angle, angle, side. What if you have two angles? What's the difference? This one has a side between them. This one, the side is outside of them. So I've got two angles and then the side that's not between them, right? So as I move this around, are there multiple triangles that can be created? Oh, this is kind of hard to move. Well, it's letting me slide that. I guess I have to slide it down here, right? So like these are the three things that can't be changed. So is there anywhere else, like is there any other place that I could, like, with keeping these two angles and this side length, there's only one place that I could stick this other side, right? Which is going to result in a certain distance between these two angles and a certain length here. As I move, let's say I moved that angle, well, now I'm gonna have to slide it down. Notice this angle's not changing, this angle's not changing, this side's not changing. As I move it down, there's only one option for another triangle. If I go, there's my triangle. If I go past this, I'm not getting another triangle with those two angles. If I go up here, I'm not getting another triangle. There's one unique triangle that can be created with this criteria. Therefore, any triangle with this criteria is going to be congruent to each other. So if I have two triangles, and I know this angle is congruent to this angle, and let's say this angle is congruent to this angle, and a side outside of them, right? This side and this side. I did the one that was attached to the one that I put two marks on. You really got to pay attention to here. So it's two angles with a non-included side. Non-included side, included side. Side between them, side that they share, side that's not shared by them is what we know. And we only need these three pieces of information in order to conclude that there is no other option. Everything else that corresponds must be congruent. right? It's a shortcut. So let's go back to this. So angle, side, angle. Angle, side, angle is when triangles have matching sides. I don't love this word, but this is coming from School Yourself, which I've done in an earlier video, and I would suggest if you're like, I need another explanation to hear this from someone else. I would suggest going and checking out School Yourself. I think it's great for this. But that word matching really means corresponding, right? So angle, side, angle is when triangles have corresponding angles and corresponding side lengths. Oh, and a corresponding side length between the angles, right? So it says circle the side that is between the two indicated angles. Two indicated angles, this side. I'm going to put a mark on it instead. Two indicated angles, this side. Two indicated angles, this side. It's the side between them. If triangles have two corresponding angles, oh, I guess it's not just corresponding, it's corresponding and congruent is what matching is meaning. Right? So two corresponding angles and a corresponding and congruent side length between them. Is that enough to guarantee that the triangles are definitely congruent? And the answer is yes. Right, as we just looked at on GeoGebra. Right, so this is angle, side, angle, congruence. Knowing this, by default, any other side should be congruent. Remember, you need two triangles. If I give you just one triangle, that I can't do that. Something is wrong. So if you are asked to draw triangles, plural, that represent angle, side, angle, and mark them off accordingly, you need two triangles. Just want to emphasize that. Let's look at angle, angle, side. Angle, angle, side. Oh no, sorry. Angle, side, angle says if two triangles have two, what word is supposed to be here? Corresponding and congruent pairs of angles and a matching, corresponding and congruent side length between the angles. That is enough information to guarantee that the two triangles are congruent. If triangles have matching angle, angle, side, so corresponding and congruent, angle, angle, side, are they definitely congruent? And the answer is yes again. In terms of A and B, what is the measure of the green angle, right? Oh, we talked about this. Remember triangle sum? So if I know these two angles, so let's say I know these two angles and this side, these two angles and this side. Okay, so A and B. Well, what do all three of these angles add to? 180. So if I do 180 minus A minus B, I'm going to get the green angle. That's what I can stick right here. So that's why this works. If I know A and B, I also know C, which we've already shown it's true by angle, side, angle. So if you know two of the angles, the third one's got to be congruent. It has to be. So that is why like this one and angle, side, angle are almost the same idea. But either one of those information, they link to each other. Because really, if you know two angles and any side, you know the third angle. So you could end up with either angle, angle, side, or angle, side, angle. So let's look at some practice. How are we doing with this? So I'm going to do all of them. And so I want you to remember that we know 4 shortcuts. We know side, side, side. We know side, angle, side. We know angle, side, angle. And we know angle, angle, side. Right? These are the 4 things that we know. So we're going to determine, do one of these apply? And if one of them doesn't, we're not going to say not congruent. Instead, what we're going to say is we're going to say not enough information, because it might not be that they're not congruent. It might just be that we don't know enough. We don't know enough about the actual triangles. And we might just not know enough in general. So let's go through some of these. So I would really encourage you to totally pause the video if you're feeling like, hey, I'm ready to try this. After you've listened to me talk for a while. And if not, maybe I'll try a few and then pause it. So here, you know what? I'm going to list off kind of what I did before. DAC, is congruent to, that's here, BCA. Okay, new color. This and this are congruent. AB, so I've got a side and an angle, is congruent to CD. Remember, this is given. I don't know if I'm going to do every single one for you guys, but I'll at least like go through the answers. So is there anything else that we, like it's underlyingly there, it's not marked off, we should look for it? Yeah, right? They share this side right here. AC is congruent to AC. Remember, that's called reflexive. So I've got these three things. I have two sides and an angle that's outside of them. Two sides and an angle that's outside of them. Is that one of the four things that we talked about? Nope. So what are we going to say? Not enough info. See how that works? Isn't that pretty cool? Let's take a look at number 2. You know what? Let's take a look at number 4. Here, we've got angle S is congruent to angle V. I can use one letter because there's only one vertex there. I need a point here. Let's call it M. Then we also know by what's marked off, so we know this and this. We've got these marked off. SM is congruent to VM. This stuff is given to us. Is there anything else that I see that's maybe not marked off that I was told to look for, that I need to really like look a little deeper? Oh, these two angles, what are they called? I can't call them angle M. Angle SMT is congruent to angle VMU. Those are vertical angles. So I've got two angles and a side. I've got two angles, and check that out, the side that is laying between them. That's one of the ones we just learned. Right? So these are going to be congruent by angle, side, angle congruence. And so we can say triangle, remember I control the first one, SMT is congruent to triangle. Well, S corresponds with V, M corresponds with M, VMU, by angle, side, angle congruence. So for these, and I'm not going to fully write these out. I would love if you guys tried them. I'll tell you the answers though. So for these two, you've got two angles, right, that are corresponding and congruent, and they share this side, which is known as the reflexive property. So these two triangles, and I could say LMN is congruent to triangle. L is up here. What does it correspond to? I should be starting with triangle N over here. I need to move myself. M, I went up here, so NO, L. By, I've got two angles and the side between them. What about this one? I see two sides, and I see this side that is congruent to itself by the reflexive property. So I'm able to say triangle KXZ is congruent to triangle. What did K's correspond to? Even though it wasn't marked off, it's actually congruent to Y, right? Because this is enough information for me to conclude that. Any corresponding, once we know the triangles are congruent, any corresponding part is going to be congruent. So KXZ, Y, XZ, by side, side, side congruence. So I have a few more practice problems over here, and I'm actually just going to write the answers. I'm going to talk through them. I'm not going to write them out so formally. I keep saying the same thing, sorry. So these two right here, I only have two pieces of information. Right away, not enough info. They're not necessarily not congruent, I just don't know enough. Number 6 right here, I've got these two angles, these two sides, and when I look a little deeper, I see these two angles because they're vertical. Right, and I'll write them out. Angle X, V, XP, V is congruent to angle XPV, TPR. Because they're vertical. And be careful of your notation here. Therefore, I've got three pieces of information. I have angle, side, angle. The side is between them. This right angle means that they're congruent. If you have two right angles, all right angles are congruent to each other. So I could say that triangle, and be careful with your angle versus triangle symbol, RTP is congruent to triangle, RTP, VXP, by angle side angle congruence. What about this? I've got two sides and an angle between them. Two sides and the angle that's not between them. Certainly not enough info. We just don't have the right info here. Right? That's not enough information for me. What about this? It's all like at the surface. It's given to me. I like walk into the room and I see them. I see everything marked off. Automatically, everything's given to me. TRL is congruent to triangle. Be careful with that symbol. T corresponds, so it's between 2 and 3. N, R corresponds between 1 and 2. And QM, by side, side, side congruence. Okay. The last two. If you haven't paused the video, do it on this. So here I'm given two pieces of information. I can see that TJ and LJ are congruent because it's given to me. I can see that VJ and MJ are congruent because it's given to me. And is there anything else I can see? These, why are those congruent? And I would say angle TJV is congruent to angle LJM because they're vertical. That's not my triangle congruence statement. That's just an angle congruence statement. Therefore, triangle TJV, look, it looks very similar, so be mindful of that, is congruent to triangle T corresponds with L, J corresponds with J, M, by two sides and the angle between them, congruence. And finally, last but not least, look, I see CA and BD congruent. It looks like there was a rotation that happened. Same thing here, a rotation that happened. Don't forget about their rigid transformations. CD is congruent to BA. So I've got two sides. Is there anything else? Yes, this side that they share. AD is congruent to AD. Oh, that is interesting looking. By the reflexive property. Therefore, right, this is not proving the triangle is congruent. I need to actually write that final statement of ACD is congruent to triangle. A is between blue and green, so it's going to be D, right? Be careful there. D, B, A, by, I had three sides, side, 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 congruence. Amazing. So we just really built on what you did in class and what we've done. And so you've now learned side, angle, side, 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 angle, side, angle, and angle, angle, side congruence, right? These are the ways that you have learned to prove two triangles congruent. You need two triangles. So I do think, like, be mindful of things like the vertical angle property and the reflexive property, that you're looking for those. Like, be on the lookout of them, and also be mindful of your notations, right? Like, know the difference between how do you write a segment, how do you write an angle, how do you write a triangle. These are the shortcuts that we are using. You can essentially, even if the question's not multiple choice, make it multiple choice. Right, you've got 5 options right now. Side, angle, side, 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 angle, side, angle, angle, side, or not enough information. Okay? So what your job is now is to complete the post-lesson check-in. So hopefully you've taken notes on this. If you need to go back and review anything or use any of the supplemental resources to maybe practice before you do it, your score, we want you to complete it to provide us information. You actually can complete it as many times as you would like. Right? So you can do it and be like, you know what, I really struggled on this area. Go back and practice it and go and redo it, right? Like, use it as a resource to really experience test-like questions. It is a grade, but it's a completion grade. Okay, so thanks everyone for watching, and I will see you next time.